No, stars. Today we're going to hop into something pretty challenging, but it's very useful for you going forward. And what we're going to talk about, you rock stars, is we're going to talk about writing one-step linear equations from context. So kind of a crazy big title, but what that really means is seeing a real-world situation or seeing a sentence that is written with mathematical words in it and turning it into an equation, which is why we learn math. We're learning all this math so that we can use it in the real world. And this is going to kind of help us at the very beginning stages what that means. I got a pretty easy one for you today. What is the math teacher's favorite dessert? Think about it. It's pie. Pie, pie, pie. That's super easy. Okay. So what your goal is today is you're going to be able to write a one-step linear equation. What is a one-step linear equation? Well, we went over this in a previous video. So if you haven't looked at modeling one-step linear equations or solving one-step linear equations, that's where what these are. And basically a one-step linear equation means you have a variable like c, and it's going to have only one thing you need to do, like c minus 5, and it's an equation, so it has an equal sign, equals 11, or d divided by 4 equals 16. So all these have one step. So we're going to be able to write one of those based on reading a verbal situation, which is just mathematical words written in an order so that you can try to decode them and write yourself a linear equation. Or we're going to be able to read a contextual situation, which is, that's kind of a fancy word for word problems. Like, can I take a word problem, put it into a one-step linear equation? All right. So turning scenarios into one-step linear equations. So for us to take a scenario and be able to write a one-step linear equation, which is really important, you're going to need to take a sentence or a scenario and turn it into an equation so that you can solve whatever this thing is, all right, whatever's missing. All right, and so you're going to need to use some of your knowledge that you've used in the past for breaking down word problems. And a lot of that has to do with like looking at the words that are in the word problem, and those are like clues, right? If you haven't seen my solving word problems, multiplication, division, check those out because I have this detective scenario that I use on how to break down word problems to solve them. And so we're looking at like phrases and sentences and words that will kind of give us some clues. Here's some examples: more than, less than, product, which is the answer to a multiplication sentence. Is, I have in all caps because I haven't really talked about that in too many videos. But if something is something, is going to be our equal sign. All right, and I'll show you quite a few examples of that as we get going. Quotient, so a lot of vocabulary. The answer to a division problem, difference, the answer to a subtraction problem. You've seen all these words before. So we have to be able to use those words to turn it into an equation. All right, so let's try a few. So our first one says k increased by 5 gives us 8. So let's look for some clue words here first of all, okay? So we know k, that's a clue. That's our variable. And it says k is increased by. So let's think about what we understand about increased by. So if you had a pile of Cheerios here and someone increased it by putting Cheerios on it, increased it, it's going to go up, right? So in other words, you're adding those Cheerios to your pile. So this increased by is the same thing as addition. Okay, and then over here we have gives us 8. So that's kind of a tricky one. You're not going to see that very often, but what we know over here so far is k. Okay, so if we take k and we increase it by 8, we're going to get gives us, which means equal to. It's going to give us. I'm sorry, I wrote that wrong. K increased by 5 is going to give us 8. And so that's what that phrase means. K increased by 5, okay, so that means k plus 5, gives us, it's going to give us a new quantity, which is going to be 8. And this is what we're doing today. We're kind of breaking these down so that we can get to a final equation. Okay, we're not solving them today. We're just trying to write the equations. So the total of Q and 1 is 25. So let's look for buzzwords. I see total. That's going to be a big deal. Total means like, like you've got some things, you got some other things, and when you total them, you have this one other thing. So the total of Q and 1. So it wants us to total up Q and 1. So it sounds like another what? Addition problem. So Q and 1 is, and is that equal word, is 25. So Q and 1 is 25. All right. So Q, let me write Q a little better. Plus 1 equals 25. Q and 1, that's our clue. Okay. All right. Now let's check out another one. So the product of 3 and P is 9. So what do you see there? Do you see any clue words in there? Well, one of them is the thing that we just sort of talked about a second ago, which is product. And this is a vocab word, okay? You need to know this as a mathematician. Product is the answer you get when you're multiplying numbers together. So the product is telling us that we are going to be multiplying, okay? And it wants the product of 3 and P. So what do you think it wants us to do with 3 and P? It wants us to multiply them together. So, and in algebra, when you're writing equations, you don't put 3 times P. You don't do that because this could be a variable. You say 3 and you put the variable right next to it. The coefficient goes first, which is a number that we're multiplying by a variable. So we say 3P. All right. So, and then we say it is 9. What did I tell you that is 9 equals? Is 9 is the same thing as saying equals. And then what does it equal? It equals 9. 3P equals 9. The product of, okay, 3 and P, so that's why we multiplied those together, is 9. All right, let's try another one. Okay, so now we have 1/3 of Y is the same as 4. All right, well, 1/3, that's not really a buzzword, but that tells us it doesn't put the numbers in there, it puts it in word form. But 1/3 is a way of saying a fraction. 1/3 of Y. So of is one of those buzzwords that we use for multiplication. 1/3 of Y. 1/3 Y is the same as. Well, what does equal mean? It means whatever I have on one side has to be the same as whatever I have on the other side. So that is code for equals. 1/3 of Y is 4. There we go. 1/3, wrote the fraction, of Y, there's our times Y, is, there's our equal sign, the same as 4. Is the same as, which is our equal sign, and then 4. All right, let's try another one. All right, we're looking for two things. We're looking for keywords. Okay? We're looking for keywords like less than, is, equal to, multiply, all those things we just talked about. And we're also looking for the unknown. What is missing? We have to know what is missing because that's going to be our what? Our variable. So we're looking for keywords and the unknown. What does the variable represent in a word problem? The unknown, okay? The unknown. It represents the unknown, what we're trying to solve, okay? So what the unknown is, the variable represents the unknown, which is also going to be our answer, okay? And what happens after we figure out the equation needed to solve the word problem or scenario? After we read our problem or our real world situation takes place and we listen for our keywords and we figure out that what we're going to do with that is add or subtract or what it needs to be, and we set up our equation by knowing what the variable is, and we know that if we can solve that variable, we're going to get our answer. What happens after that? Well, you solve it. After you solve it, you solve the answer. And what I mean by that is you are going to figure out what the variable that was missing. Now you know what you were trying to find. We need these equations so that we can break down problems, put them into an algebraic equation, a one-step equation in this incident, and then that will give us our unknown. And when we know our unknown, we know the answer. So that's why we do it, folks. All right, let's get rolling. So I think you guys understand. Look for the buzzwords, look for the keywords, understand which ones work with operations, which operations you're trying to solve, and then be real careful with the order that they are in. What do trees eat for breakfast? Oatmeal.